This is a question from exercise 12.2, question number 7 of your textbook. We've got a 10-year mortgage of $150,000 at an interest rate of 4.5% compounded semi-annually for the first 5 years. And during the first 5 years, you're asked to determine the size of the monthly payments, and also would like you to round it up to the nearest, the next $10. And then the second question is, what's the balance on the mortgage at the end of the 5 years? And then the third question is, during the last 5 years, what is the size of the monthly payments rounded up again to the next $10? What was the size of the final payment on the mortgage? So I'm going to start off by taking a look at a time diagram. In order to deal with a 10-year mortgage initially, what we're dealing with is 120 monthly payments at the end of every month. We'll always assume that the payments are at the end of every month unless you're told otherwise. So we've got 120 payments of our dollars at the end of every month. So there's our time diagram for a present value mortgage, because initially the present value of the mortgage is $150,000. So we've got 150 grand as our present value. You'll notice that you've got monthly payments and you have a semi-annual rate. That is a conflict. What that means is that you're dealing with a general annuity. And what this also means is that when you're treating this on your calculator, you're going to need to remember that the payments per year are equal to 12, because there are 12 monthly payments per year, and the interest periods per year, the compounding periods per year, are 2. So they are. So your calculator will deal with the issue of equivalent rates for you because of that built-in function. It's a very nice function. So now let's first of all determine the answer to question part A. So in part A, what we need to do is to find the payment for the first 5 years. So in spite of the fact that we've got a 5-year period here, we're still dealing with the fact that we need to amortize the mortgage over the 10 years. And so what that means is that N is equal to 120. The present value on your calculator will be equal to $150,000. And the I/Y is equal to 4.5% per year, compounded semi-annually. So C/Y is equal to 2, compounded semi-annually, and P/Y is equal to 12, because there are 12 payments per year, and there are 2 semi-annual periods per year. And then we'll go second quit once we've finished entering in our interest information. I think that we now have all of the details that we need. So we've got N is equal to 120, PV is equal to 150. We are now ready to compute the payment. And when you compute the payment on your calculator, I believe that you will get a value of and your answer will be negative 1551 and 568 and so on. And of course, at this point now, what you need to do is to round this off to the nearest $10, or to the next $10 actually. You were told to round it off to the next $10. And so we're not going to round it off to 1550, we're going to round it off to 1560. So the payment is going to be $1,560 per month, and what you're going to do now is you're going to enter that as your PMT. So for the next stage, you're going to make sure that you pump into your calculator that the payment is equal to negative 1560, because remember that initially our payment came out as a negative value, so we're going to pump that back in as a negative 1560. So that's our new payment. That's going to replace the payment that was computed of $1,551 and 57 cents. We're going to replace that with this payment. And now we're going to key in second amort. And the reason why we're going to do this is because we want to figure out the outstanding balance after the 60th payment. So we want to know what the balance is after the 60th payment has been made. Or in other words, at the end of the 5th year. So how much is still outstanding on this mortgage after the 5th year. And once you pressed second amort on your calculator is sitting there waiting for you to enter in the P1 value. You're going to enter in P1 equals to 1, press the enter key. P2 is going to equal to 60, press the enter key as well. Remember that you need to press the enter key after every entry in order to go down to the next level or the next stage. And the calculator will now compute the balance that is outstanding after the 60th payment. And your calculator should give you a value of $82,744.20. And that is how much is still owing at year 5. And now what you're going to do is you're going to enter that as the present value for the remaining 5 years. And so now for the next 5 years, the present value is equal to the outstanding balance at the end of the first 5 years. And that present value is $82,744.20. And of course, remember that if you're still in the amortization function, you're going to need to press second quit to get out of the amortization function, and so that you can get back into the computing function. So now we've entered in the present value is equal to $82,744.20, and now you're going to change the end value to 60 because there's only 5 years left in the mortgage. So there's 5 years remaining in the mortgage. You do not need to change the interest rate, although typically interest rates do change from one mortgage period to another, but the IY is still equal to 4.5. The PY is still equal to 12, and the CY is still equal to 2. So you don't have to change these if they're still in your calculator. There's no need to re-enter them. And now at this point you can compute the payment. You can compute the new payment, and that new payment will compute to a value of $15.4104. And of course your calculator is going to give this to you as a negative quantity because it's the opposite of the present value entry. So you realize that what this means is that your monthly payment now needs to become $15.4104. We want to round this off, round it off to the next $10, and we're going to round this off to $15.50. So for the next 5 years you're going to be making payments of $15.50 per month. Now, once you've got these payments of $15.50 per month, you're going to overwrite the computed value by entering in payment equal to negative $15.50, and you're going to go to second amort one more time, because what you want to do is to find the size of the last payment. The final payment being the 60th payment. So how do we find the size of the 60th payment? Well, once we've entered in second amort, we're going to go to P1 is equal to 1, P2 is equal to 60, and your calculator will tell you what the balance is after the 60th payment. After the 60th payment of $1,550. And so your calculator will give you a balance of negative $601.23. Now what does this mean? What this means is that if you have a negative balance, it means that you have overpaid with the 60th payment. So since you've overpaid with the 60th payment, what you can do is you can deduct $601.23 from the $1,550, and so your 60th payment, or your final payment, is going to be equal to $1,550 minus $601.23. Whatever that number is, I think it's $948. So it'll be $948.77. So your final payment needs to be $948, and your other 59 payments are going to be $1,550.